So today I'm going to talk about Algorithm Design, which is a book published by Steven Sekina. And jumping from introduction, I'm just going to get to the main idea of the book. So algorithms are our way to resolve and automate the real world problems that we have using computers. And when we design algorithms, we mean that we need to design how the algorithm, or let's say the set of instructions that the machine should do. So we're just trying to translate our solution of the problem and the machine way of thinking. Leave aside the coding, it's just how we're going to design the solution itself. And as the problem gets more complicated, trying to translate that solution, I mean, the solution itself is going to be complicated, but designing the translation of that solution to a machine way of thinking can get a little bit challenging. And one of the big problems is people want to try to build their algorithms, the big aspect they always think about it and they think it's a problem, but it is just a part of the problem, which is the performance and the efficiency of the algorithm. But that's not the first aspect they should think about. The most important aspect is the correctness of the algorithm, making sure that algorithm will run and be reliable at any cases of the problem. And you might think that an idea seems reasonable and gives you a good result in a set of examples is enough, but that's not the case because in a real life problem, we can get that, we can have it in a different shapes and different abnormals, uh, aspects of that problem that can make our solution or our algorithm behave differently and not expect that type of inputs from it. So one of the big aspects is to have a correct algorithm that can resolve and can treat any case of that problem. And a correct algorithm should be justified before implementing, either by questioning the correctness of it, by giving it counter examples and trying to disapprove or try to approve the weakness of that solution you implemented. Another way is you use mathematical inductions if the problem is recursive or incremental by assuming a set of a problem is correct in any case, then testing in a bigger scale like n+1 or another scale with that and proving it with that first assumption. And besides the correctness, once we have the correctness, then we need to think about the performance, because the performance is a one big aspect too that is important since our computation is a limited resource. And besides that, the problems that we tend to resolve sometimes need to be resolved at real time, which we need to make sure that the algorithms that resolve it are really fast to resolve them at real time. And one way to measure the performance is through big O notation, where we tend to calculate the function that give us the scale of the execution time of that algorithm through the scale of the number of inputs that we give it, or the number of instructions that get scaled through the input. And one of the big aspects to reduce the performance is the type of data structure that you use in your algorithm. Give it if we're gonna have an algorithm that needs assorted data, so it can get the least value or the max value, or we just need a data set that we just input or insert data on it without caring of how the structure is gonna be. So these type of data structures differ, and each one has an advantage and disadvantage. We cannot have a one data structure that is fast at everything. We need to have there is a sacrifice at each part on a data structure. So we need to choose wisely what we need to use that data structure for and use the best one for that algorithm. And that's mainly what the book talks about, the first chapter. And thank you for watching.